for the first time. They are out for a girls' trip. They are going 120 kilometers an hour east, consider east the horizontal, in their car that weighs 1,500 kilograms. Owen and Sam are sitting in their 1,300 kilogram car at rest on the side of the highway, trying to find directions to the beach. As Breah and Addison are passing Owen and Sam, they collide. Breah and Addison's car goes 70 degrees north of the horizontal, and Owen and Sam's car goes 48 degrees south of the horizontal. What are both cars' final velocities after the collision? So we will start by drawing a diagram of what the cars were doing before the collision. So here is Breah and Addison's car that weighs 1,500 going in this direction, and we will convert the 120 kilometers an hour to meters per second, which will be 33.33 repeating meters per second, approximately. And then we have Owen and Sam's car, which is 1,300 kilograms and is at rest, which is 0 meters per second. Then we have the diagram after the collision, which is a bit more complicated. So we have Breah and Addison's car, still weighing 1,500. We have V1X here, V1Y here, and then we have V1 prime right here. And this is the 70 degrees north of the horizontal. And then we have Owen and Sam's car, still weighing 1,300. We have V2X here, V2Y right here, and then we have V2 prime labeled right here. And then this is the 48 degrees, which represents the direction in which they went.
Okay, now for the y component. We are going to be using this equation. This is because momentum is conserved. So the initial momentum on the y direction is going to be equal to the final momentum on the y direction. Now, both of these are 0 because Breah and Addison's car was moving in the x direction, so therefore they have no initial y component, and Sam and Owen's car was at rest, so they have no initial y component either, making this side equal 0. Now we're going to sub in all of our values, and we're going to use sine remember, the 48 degrees is a negative direction. So now we're going to move the negative 966.09 over to the other side.
We are now going to isolate V1 prime. To do that, we just divide both sides. We are now going to use this equation and this equation up here. And to solve for v2 prime, we are going to divide both sides. Which will give us 40.93 meters per second equals v2 prime. Now, to solve for v1 prime, we are going to use this equation here. So v1 prime is 28.05 meters per second, and v2 prime is 40.93 meters per second. So that is what each of these values is. So Breah and Addison's car is going 28.05 meters per second after the collision, and Owen and Sam's car is going 40.93 meters per second after the collision.